Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. How are you today? Today we will talk about application of the derivative by Ms.Rara. So, in application of the derivative divided by 2, the first is about application of the first derivative. The second one is application of the second derivative. But today we will continue about application of the first derivative. Last meeting we already learned about interval of increase and decrease, and then absolute and the local maximum and minimum value. But today we will learn about finding the local extrema. Finding the local extrema, from here we have the graph. We have the graph and the local maximum in here A, because the it's not the absolute maximum, absolute minimum in here, and then local minimum in B, because local not absolute, because in here the absolute one about minimum. From here we are see the blue line. The blue line is showing that horizontal with what? This is horizontal and then parallel to the x-axis. Because this one is parallel to the x-axis, they have slope 0. So slope equal the first derivative A, and then the first derivative of B is equal 0. So theorem, if f has a local extremum, Miss, I forget what is extremum. An extremum of a function is either maximum or minimum value of the function. So if you don't know what they ask, like they just ask local extremum, so you need to find the derivative. After that, you make a chart sign. What I mean, and then and then the first derivative is axis. I mean the c is axis, and then the first derivative of c is equal 0. So example, the function of x is 2x power 3 minus fx plus 5 has local minimum at x equal 1. Find m. Solution, because we know this have local minimum. Local minimum is a part of local maximum, so you need to derivative about this function to be 0. So this one you have 0, but they have local max minimum at x equal 1, so you need to substitute x to be this function, and then when you substitute you get the m equal 6. You understand, everyone? Did you understand? Okay. In example, find the local extrema of the function fx equal absolute x. Let us plot the graph of f. Fx equal absolute x. Absolute x is have two meaning, plus x or minus x. If plus x, x more than equal 0, and minus x, x less than 0. We see that f has local minimum at x equals 0, right? But there is no tangent line, and f prime x is not defined. So x equals 0. So that's it, guys. So you just have the local minimum at x equals 0. Definition about critical point. The value of C in the domain of F is called critical point. So C is the constanta. Yes, the constanta. So if you want to get the critical point, so the first derivative it should be 0, or when you substitute the C doesn't exist. Okay, remember. So in here, example, find the critical point. Fx equal to x power 3 minus 9x squared plus 12x minus 7. Solution. So you need to derivative about this one equal 0. And then you will get 6x squared minus 18x plus 12 equals 0. So you need to have a root of this one. So you will get x equal 1 or x equal 2. So that's the critical point since derivative equals 0. So this x is showing that critical point. So they ask again, find the critical point of fx equal x squared minus x minus 1. Because this is the quotient rule, and then we know since this one critical point is the first derivative is 0. So you need to using the quotient rule to get the derivative. From here we get the derivative. When in the numerator we get the x equal 0 or x equal 2. But from denominator, in denominator f the prime x doesn't exist at x equal 1. So the critical point is just 0 and 2, everyone. So thank you for today. Please do exercise. Check yourself 5 on page 96. I hope you enjoy my video. Thanks. Assalamualaikum warahmatullahi wabarakatuh.